Welcome back, everybody, to HashrateUp. This week we have Matthew Carson, CBO over at Hash House. We talk about hydro versus immersion, get a bit sidetracked. They have a solar kit as well, which we didn't get to speak about, unfortunately, but we will have to do that next time. Matthew has been a great interview partner, and I hope you enjoy. HashrateUp, hardware sales, advisory, hosting, and site brokerage. Find new and used ASIC deals through the website and the Telegram channel below. Make smarter decisions with HashrateUp. All right, so like I said in the brief introduction, I am today with Matthew Carson, and he is CBO at Hash House Company Incorporated. Remind me, Matthew, in Shenzhen or Hong Kong?
Hong Kong.
Hong Kong. You guys produce infrastructure, mainly containerized systems. You also have I want to call it solar capture hashing system. Today we're going to talk a bit about that, and first of all, give you a chance to just highlight Hash House and what you guys are all about. Go ahead.
Yeah, so the quick and dirty is Hash House is a somewhat fully integrated infrastructure for mining. We have our line of immersion cooling products for all the major manufacturers, both containerized and what we call skid mount built into the building, as well as for hydro. We also have our own line of transformers that we manufacture. And we're actually hopefully going to be getting into the genset and generator manufacturing line as well here shortly, due to, obviously, with everything going on in the world, the massively increasing demand there.
Yeah, for sure. Matthew, before we get into anything, I unfortunately couldn't be in Vegas. You were part of a panel there, which is why we're also here today. Can you talk a bit about the panel and what you guys discussed, what it was about, and maybe give me a bit of your feedback on the conference when it comes to Bitcoin mining and the mining angle?
Yeah, the panel was just sort of a multi-industry disciplinary look on basically hydro versus immersion. What's better? Where does it work? Where doesn't it work? It was myself, a gentleman from Exxon, and a very nice lady also from China who manufactures aluminum fin dry coolers.
What was the guy from Exxon doing at the conference? What was his angle? Was he pro, anti, neutral? What was his feelings around the industry?
So he comes from their immersion fluid department. So he was obviously a little pro immersion, but he came from a very strong traditional data center background with a lot of hydro experience as well. So it was a pretty well-rounded panel. None of us were particularly biased, I guess you could say, in one direction or another for immersion versus hydro.
What's your take, though? If you would deploy a megawatt today, if you were a customer of your own products, hydro or immersion?
So it's a hard one for me. So from a personal standpoint, as someone who grew up from a very young age building my own water-cooled PCs, I sort of have a strong aversion to water anywhere near electronics, whether it's, distilled water, deionized. Just from a simplicity of infrastructure standpoint, especially with mining, the simpler you can make it, the less, let's say, the customers and clients can break it, so to speak. And hydro is just a little bit more complex, quite a few more points of individual failure. But unfortunately, in Bitcoin mining, because all of the manufacturers have decided to have different form factors, different input voltages, different flow requirements, immersion is sort of fragmented across all the different manufacturers. So it is very hard for me, although personally I like immersion better, for longer term infrastructure, which is, when you're building hydro and immersion infrastructure, we're no longer worried, like, I just need my building or my container to last, a year and a half to 2 years till it's paid itself off and the miners have paid itself off. And, I don't necessarily care to, now looking to buy infrastructure. I want this to work for 2 or 3 or 4 generations of miners, because that's just where the market's going to.
Okay, so if you had to decide, you buying hydro or immersion?
Hydro. These days, hydro.
All right. I agree with you. I mean, we've seen a kind of a convergence, I guess, to the 2U form factor. It's only Bitmain that's kind of dragging its feet, I guess, except for the one model that they have aimed at institutional miners, which now is curious because they're all pivoting to AI. Who's got the money to buy S23? I don't even know the model number of that 2U unit that they have. But if you had to summarize that, I guess, like if you say hydro, I would assume your customers agree with you. What models are they buying, and when do you decide to buy Orodynes, MicroBTs, Seal miners? And yeah, talk a bit about the buying choices there and what's important.
So funny thing about the S23 2U model is it's still not compatible with everyone else's 2Us because they use a different plug at a different voltage, and the water connections and the power connections are on the opposite side of the miner of everyone else. So from an infrastructure side of things, like for our hydro products, we effectively have two different lines. We have the Bitmain line of hydro products, which is then split into two because you have the shoebox design of hydro, and then we have the Bitmain style 2 or 3U. Then we have the everyone else Canon, AlphaPex, Orodyne, MicroBT, BitDeer 2U style hydro infrastructure.
Yeah, it's curious. Is every container that you make custom made for the customer? What's the lead time on those units? Or do you have units in stock that just fly off the shelf?
So we have some units in stock, and the ones generally that we keep in stock are the everyone but Bitmain 2U hydro design because they are the most, let's say, universally applicable between different customers and clients worldwide.
Okay.
But we have what we call like our standard models that are, you can see them on our website. We've got the standard spec sheets, but interestingly enough, and through our engineering process, actually not a single one of our customers has the same product of any other customer. As part of our sales onboarding process, we get very deep in the weeds with the client to what do they actually need, what are they actually willing to pay for, the year-round climate data going back several years, curtailment requirements. Are you grid powered? Are you gas powered? Like I'm just working on a client right now that has a need for 2.4 megawatt containers, but they need to be able to use two 1.4 megawatt generators to power the container, which requires a completely different, what we call main input feed into the container design than, say, one you're just connecting to a standard transformer connected to the grid. So we take a very highly individualized project by project view with our clients.
And is that also where you would say Hash House and competition differentiates itself from each other? Because I often,
Yes.
from the surface, it's very tough to understand where the differentiating factors between all the manufacturers are, and how to convince customers to pay a premium over maybe a competitor that just tries to get container products as cheaply on the shelf as possible.
The way I like to describe it is we take a very hands-on approach with the client from start to finish, including, for deployments, we have our guys on site with them to do training, energization. I personally have done several site deployments this year where I'm actually getting my hands dirty and I'm helping them unbox miners, rack miners, plug them in, energize the containers, things of that nature. But really, our approach is that nothing we sell is something that we would not run ourselves, like that we would not personally buy ourselves and run ourselves. And in fact, we do in several locations.
Okay, we'll get to that. I want to hear about the deployments as well, and it sounds like you do self-mining as well. But before we get there, what is important, Matthew? Like when you look at hydro containers, what are the things that people and your clients most often miss or don't think about when they think about the systems cooling their most precious Bitcoin miners?
I think there's still a lot of holdover from the air-cooled days of how many S19s can I throw in a container in a field and get them running as quickly as possible sort of mindset, instead of, like we spoke a little bit earlier about, choosing infrastructure that's going to actually outlast not just one generation of miners, but several generations of miners that won't require significant refurbishment, repair, or even in some cases, complete replacement.
Buying Bitcoin miners should be simple, safe, and fast. Altair technology delivers exactly that. Based in the US and shipping directly from St. Louis, Altair eliminates all the shady messaging groups, customs and tariffs issues, and makes sure Bitcoin miners get to you on time. Altair stocks leading commercial ASIC miners, efficient home units, and all the critical parts you need, backed by real inventory, real support, and a team of people that you can rely on and actually mines Bitcoin. Thank you so much, Altair Technology, for supporting the show. And without further ado, let's get back to it. Okay, and what makes that? Like, what if I buy a container that's going to last me for 30 years? How is that container different from a container that'll last 4 years?
So a lot of it comes down to, of course, the quality of the components. Generally speaking, we're using all very major brand components. We're using ABB, we're using Schneider, we're using Noark, all UL listed components. Our containers have passed multiple UL field certifications as a whole package, using open, well-known communication protocols with, the main breakers, the PDUs, having just a higher quality of component with a higher level of underlying engineering. Our manufacturing partners that we work with in China are those who not only build but also operate a large majority of the traditional data center and AI data centers for Tencent, Alibaba, the Chinese government. So the tier 3, the tier 4 equipment manufacturers, where we're effectively telling them, we need to dumb down the products that you currently make for a more simplistic client at the end of the day, rather than I need to deliver hydro infrastructure at $50,000 a megawatt delivered to the customer.
Yeah, we need tier 0, not tier 4. And then, do you see more people also? And we spoke a bit about the volatility and the hash rate and the difficulty and the boom and bust cycles and stuff. My question, I haven't fully formalized it in my head yet, but my question is around people thinking longer term as we see difficulty steps decreasing, and in general, those people who decide to start mining today having a certain view on the market, right? I feel like a lot of the investors that think for the next 2 years are kind of out of the market doing something else. And you're gotta really understand Bitcoin mining and have a view of where it's going to still bet on it, if that makes any sense. So, I mean, we've come from what, 30, 40 joule per terahash machines, not even 10 years ago, to now sub 10 joules, but the steps of efficiency are lowering. So my question, I guess, is a bit about where you see difficulty hash price going, and if there's a connection from that to what equipment do people buy? Do they think more long term? Do they want to run their machines not 3 years ROI them, and then whatever happens to investors that want to run them for 10 years? And then I guess we can also talk about manufacturing quality, but let's start there first.
So I think, we've sort of started to see, and we're in the midst of the migration of the plug in and run it at any cost, just get me a grid connection somewhere, I need to start mining Bitcoin immediately crowd. That crowd, those power opportunities have now entirely, or in the process of migrating to HPC and AI. Because of course those compute loads have much higher capital raises, much deeper pocketbooks, and that, of course, that compute generates a lot more profit when active on a per kilowatt hour basis. And I think now we're seeing Bitcoin mining and those who are still, investing, building new sites are really starting to target, let's call it what used to be the edge cases, the sheddable loads, the curtailable loads, the completely off grid where you can't get any bandwidth, things of that nature, to really, really drive down ultimately their kilowatt hour costs because they've realized, it's better for me to be at 85% uptime if I'm paying 2.5 cents per kilowatt hour versus 3.5, 4.5 cents, which now we're even seeing prices like that for curtailable load, like in West Texas, realizing that, if I can give up the top 15% of my hashing hours in order to have my 24/7 power price, fixed on that lower end, that yes, my time to ROI may be longer, but the market conditions in which those players can remain overall profitable is much more flexible and much more well suited to long-term profit generation. Because, even with current Bitcoin price, even with difficulty decreasing, you're looking at 18 months, 24 months to return your investment on the miners and infrastructure. So it might be better to stretch that time period out, so to speak, on your spreadsheet, another 6 months. If past that 6 months, you can remain profitable for a much longer period of time. The way I like to think about it is, it's not, the dollars of revenue you're generating right now. It's what's the total amount of realized hash rate your miners, your infrastructure, your site can generate over the lifespan of all the equipment. Okay. So by choosing you're looking at sites with less uptime, lower power price, better infrastructure, and longer longevity miners, that realized Bitcoin mined over a 3, 4, 5 year period is going to be higher than the ones who went, give me the cheapest, most efficient miners and the cheapest infrastructure wherever I can plug them in the fastest.
Okay. So it's interesting because now, are you talking about an approach, Matthew, where you basically say, okay, what's the total volume of hash that I can produce and how much do I pay for that? And if I use cheap containers, I'm going to have to buy new ones sooner. And if I use quality ones, I guess per unit of hash dollar spent is lower, even though the upfront capex might be higher, correct?
Yep.
Okay, so the biggest piece of that puzzle is what units do I buy? So if you deployed today on gas 2.4 megawatt container that is now effectively split into two because you have two generators powering it, what units do these people buy in a dusty off-grid environment that are reliable, they don't need a lot of maintenance, and they just run without fans breaking every week?
The miners I'm seeing them buying, or the miners I think they should be buying?
Let's answer both.
Two different answers.
Please. Yeah. Go with both.
So the miners I would buy would be Canaan, MicroBT, and Bitdeer. They have basically within a spitting distance of each other, very similar robustness of the miner, ability to accept a wider range of temperatures, both on the extreme cold and the extreme hot side. Both have a robust, customer service after sales, and then when you're out of warranty, a large enough aftermarket parts market to keep your fleet alive at the lowest, operational costs. Unfortunately, what I see a large portion of the market doing is continuing to buy whatever Bitmain's latest and greatest, most efficient, cheapest price miner. And a lot of those customers are now running into financial difficulties and or just problems keeping their fleets online enough to do, like we just talked about, keeping your hash rate availability as high as possible.
Yeah, why do you think they still do that? If when we just said, The differences in efficiency are not that great anymore. Who cares about a 5% difference if you're going to pay 20% less? Why is that still such a prominent dynamic when it comes to purchasing decisions, you think?
I'm being very overarching here, but I'm sure you can agree with at least part of this. Generally, for the large, especially the larger projects, those who are making decisions are basing it off of Excel spreadsheets and financial modeling that is not very based in reality. I could not count the number of 20, 30, 40, 50 megawatt projects that were given go, no goes basically based on what is in the Excel document, and that those documents never took into account DOA rates, average failure rates, repair times, repair costs, infrastructure failure rates. All they looked at is I've got my equation of how much hash rate I'm generating, therefore how much revenue I'm generating, and therefore Bitmain being $2 a terahash cheaper and 10% more efficient with infrastructure that's 30% cheaper. Well, look, over the 3-year timeline, I'm going to generate 50% more revenue than this other option, without realizing, maybe you get a bad batch of S21s or S23s, 25% of them are dead on arrival, and it took 9 months to get that fleet back up and running. Well,
Yeah.
if you do a really in-depth modeling, it turns out, if you have over, and these are not real numbers, I'm just pulling them out of my head. Turns out if you have over a 10% DOA rate and the efficiency difference is only 10%, that fleet being offline for 30 days, it flip-flops the entire equation in the other direction.
NerdX, solarmining.de, got it. Premium, made in Germany. You want to go fancy? Go for NerdX or NerdQX++ for a lot of power. Worldwide shipping. Check out solarmining.de today. It goes to what you said about total hash volume and money spent to produce it, right?
Yep.
Yeah, interesting. Okay, what is it like working in Asia, Matthew, in China today? And I also wanted to ask you about the components usage, because as a German, I see the Chinese competition being extremely strong, especially when you mention ABB and Schneider. I mean, these are both German brands, right? Do you see that the component quality is also increasing on those fronts? Why is that still so prominent, using ABB and German brands like Schneider as well on the component side? And how far are we along the road of the Chinese brands just being better?
So I would say the Chinese manufacturing, Chinese quality of, let's call them Chinese house brands, has massively, massively increased in capabilities basically since COVID, if not earlier. A lot of their products, a lot of their qualities are, you'd appreciate this, are approaching German standards, German quality control, German type engineering, I'll call it, with a holistic view on delivering a quality product to the customer, not delivering whatever product we can to the customer as long as they pay. That mindset has shifted a little bit. And funny enough, we also use Gunter and Kelvion as our primary dry cooler manufacturers. And I was actually featured in Kelvion's new global marketing video a couple weeks ago in their factory in China. So it's very interesting to see literally their quality control sheets and such in the factory are in English, Chinese, and German. And they're very German in their layout and their format. In one of my previous lives, I worked for Northern Data, the very large publicly traded Bitcoin miner, now HPC AI. So I have a little bit of insight on how German companies run. So it's very interesting to me as an American to see sort of the fusion of Chinese speed and Chinese just getting things done, combined with a more holistic view on quality and customer experience, not necessarily like wholesale volume.
Yeah, makes sense. What's the pivot to AI? How is it affecting your business?
Well, it's turned about half of my calls into a, hey, if I buy these hydro containers, can I also, buy a bunch of NVIDIA GPU servers and stick them in there too, and, make some of that, AI revenue. We like what CoreWeave and Core Scientific's doing, and we want a piece of that pie. And that's always a very fun conversation to have. Because at
No.
the end of the day, the overlap is surprisingly minimal to the uninitiated. I've told people in the past, well, you can reuse the dry cooler. That'll still work. Everything else inside, I mean, especially for like the new GB300 platform from NVIDIA, just the networking requirements for that, the core and edge switches for that, for a 1 megawatt project, exceed the cost of my entire 2.4 megawatt container. So,
yeah, interesting.
although the boxes
very cool
look
statement.
very similar and they both use power and need an internet connection, the similarities effectively end there.
Do you see that? Well, I always like to say it costs about 10 times more per megawatt to build AI infrastructure than it
At
does
least.
for Bitcoin mining. Yeah. Do you see that converging and getting smaller over time or no?
Well, I'm starting to see a different sort of convergence, which is especially these more, let's call it curtailable energy sources like grid power in West Texas, direct solar offtake, direct wind power offtake is, let's say they've got a semi-interruptible source of 100 megawatts. If they really drill down and look at it, what it actually looks like is they can get 10 megawatts of power at 4 nines, 5 nines, 6 nines availability, which would be more than acceptable for HPC AI. And then they've got this, 80, 90 megawatts of load that needs to be very flexible and very curtailable very quickly. So I'm seeing a convergence of those who are going, well, we want to do 10 megawatts of HPC AI. Our site's got the fiber, we've got the infrastructure, we've got gas for backup generators, we can get batteries. But in order for them to get that power contract at a price that makes sense, or even to get the power contract at all, it's much easier to go, I'll take all 100 megawatts of your, not always available power source. I will have my 90 megawatts of Bitcoin mining always running when those kilowatt hours are available, while my 10 megawatt data center is basically always live. And that provides a lot of operational synergies, because generally those who operate Bitcoin mines can't really do HPC AI, but especially now with hydro becoming so prevalent, if you're doing a hydro GB300 install, those guys can definitely run a hydro Bitcoin mine.
Yeah.
Basically in their down/off time.
Yeah, and then I guess you have to then look at what your kilowatt hour effectively costs if you're going to use expensive infrastructure and stick a 2U Bitcoin miner in there, right?
And for the projects we're working on, the numbers work. Presuming they have either the capital or the ability to raise the capital for the much more expensive capital requirements, the synergy between the two works very well.
The spreadsheet works. We're yet to see whether it works on a large scale in practice side, I guess. Talk to me about your deployments a bit, Matthew, before we round out. What's your sort of biggest deployment, smallest deployment, most fun deployment?
So our biggest deployment to date is 200 megawatts of immersion infrastructure for MicroBT miners for Riot platforms at their site in Corsicana, Texas. That project from start to finish was less than a 5-month process.
Wow.
From order placed to energizing the infrastructure. In fact, we were so early on our delivery that the building was still finishing construction while they were installing our tanks and dry
Super cool.
coolers.
Yeah.
We have a pretty large number of 50, 60, 70 megawatt projects, a lot of them West Texas, Central Texas, a bunch more located around the United States. We did a prototype deployment on the North Slope of Alaska, all the way up
Okay,
north.
cool.
That was probably, on one hand, the funnest deployment, on the other hand, the biggest nightmare. Because it is an
Tell me more.
incredibly remote location,
Yeah.
located out on an island in the bay where all
Oh,
the oil
wow.
and gas comes from. When I went up there in June of last year, actually on my birthday, when I stepped off the plane in Dead Horse, which is the name of the closest city, I looked at the screen on my iPhone and it said next sunset in greater than 7 days.
Wow.
So the entire time we were up there, it was in Celsius, it was between 0 and 2 degrees Celsius at the height of summer, but the sun never actually went down.
That's crazy. All right,
Yeah.
cool. Wow. I guess it takes you around the world, eh? You get the hash goes where the energy is.
Yep.
Amazing. All right. Can I hit you with a few rapid fire questions, Matthew?
Sure.
You ready? All right. What's the best KPI when evaluating a mining project you're going to implement for the next 10 years?
Kilowatt hour price.
Biggest hidden cost in hydro deployments?
Oh boy. Undersized infrastructure for your temperature environment.
On-site selection, red flags that you cannot ignore.
Permitting. Permitting and
What's
licensing.
All right. More scarce in 2026? Cheap power or great operators?
Great operators.
Okay. If price didn't matter, which ASIC model do you choose to run for the next 5 years?
Either MicroVT or Canon.
All right. Matthew, do you have anything else that you want to say? Tell people where they can find more about you.
Can find more on our website, hashhouse.tech. Can reach out to us there or on LinkedIn or our YouTube and Instagram channels. We're all pretty active. We've got teams at this point in Europe, China, and the US, and I rarely sleep these days. So always happy to take inquiry, questions, things of that nature. One thing I've really enjoyed being in this industry since the very, very early days is I love the amount of education I get to do with my customers and clients. I get to learn all I know about power generation, sheddable loads, frequency response has actually come from working with our customers and clients. Certainly more than I learned in my electrical engineering classes in college. So yeah.
All right, guys, this was Matthew Carson of Hashhouse, CBO over there. Get in touch with him for anything infrastructure, hydro, immersion, education as well. Yeah, I hope to see you next week. Cheers. Bye-bye.